So, for those of you who haven't been in here, in the course information section, I have put in the calendar. I'm sure I've told you about this already, but everything will pop up on here. I'll update it when I finish doing this lesson. Today we're doing volume of a cylinder. So, yesterday we did volume of any prism, and the volume of any prism is just the area of the base times the height. Well, another way to think of a cylinder is like a circular prism.
He's giving me a death stare.
It is like a circular prism, okay? It is not actually called...
Yeah, you keep on repeating
Ollie?
Dude. Don't hit him. No, sir. No. Go down.
Ollie, stop. It's not actually called a circular prism, okay? We don't name it that, but we can think of it like that because the circle is the uniform cross-section. Uniform cross-section throughout the shape. So, we know that the volume of any prism is the area of the base times the height. We know the volume of a prism is the area of the base, and I'll put base in brackets, in quotes, because when I say the base, I don't mean the bottom, I mean the cross-sectional base. I mean the shape that is the same throughout the entire prism. Because sometimes when people say base, they think what's on the floor, like what's on the bottom, but that's not the case here. Area of the base times the height. So when we have a cylinder, so the volume of a cylinder and I'm just going to try and draw my best looking cylinder. So there, scroll down a bit. Something like that, okay. Oh, that didn't end well. So we've got a cylinder like that. It'll have a height that is here, and we'll have a radius there. Well, we know that the volume of any prism is just going to be equal to the area of the base times the height. And again, I write AOB just to say area of base. Well, if we have a cylinder, what is the cross-sectional base, Tristan? The circle. And how do we find the area of a circle? Owen?
Pi times the radius squared.
Yeah, so since it's a circle, we just write pi r squared, because that is the area of the circle, and then we times that by the height, because this here is the area of a circle. And really that's it. There's nothing else I can really trick you with here. Okay? Volume of the cylinder is quite simple, where it's just pi r squared times height. There's only so many different ways they can ask you the exact same question. The only way you can probably trick you is if they give you the diameter instead of the radius, and then they try and shorten that diameter, because then you need the radius, not the diameter, if you want to find area. So calculate the volume oh, sorry, is everyone good?
Yes.
Yep. So we'll start with the first one. And let's say that the radius here and the height, so that's 10 centimeters. The radius is 3 centimeters. So let's try and find the volume. Well, we just said that the volume is equal to pi r squared times the height. All right. Well, Edwin, what's the radius? 3. If the radius is 3, that means we've got pi times 9. So we got pi times 3 squared. And then what's the height of my prism, Jamie? 10. So we're timesing that by 10. So we got 90 pi, which is going to be something like 280. Someone put their calculator in and figure that out? Huh? 282.74 centimeters. Centimeters what? Cubed. We are still working in volume. It's still going to be units cubed. All right. Next one. So flat 0. Okay. So we've got a cylinder. The height is 12 meters. And this length here is 800 centimeters. What's the first thing I should probably do? Lexi. We don't like working with different units. It's not going to be very nice. So let's just change this straight away to 8 meters. Okay. Once we're now working all in the same units, our problems become much easier to solve. Owen.
Oh, you need to change that 8 meters to 4 meters.
And I need to change 8 meters to 4 meters. I've been given the diameter of that circle. I need the radius so I can try and find the area. So volume equals pi r squared h, which equals pi times, I'm going to write 4 in a different color just so people know that we've changed it from 8. And then times that by 12. So now we've got 16 times 12, so that's 160, 192. 192 times pi, which will be close to, let's say, 570 something. Can someone confirm or deny? Oh, I was going to say 600 and I underguessed it. Damn it. That would have looked so good. So 603.18. 18 or 19? 19 meters cubed. Okay? Now, if I would have left that in centimeters, and I would have left this in centimeters, I would have had a situation where it would have been pi times 400 squared times 1200, right? And that would have given me my answer in centimeters cubed. It would have been much, much bigger than this, which is why we need to square our conversion rates every time we're converting between units with volume. Sorry, we have to cube our conversion rates when we're dealing with units and volume, because you need to take into account the zeros that you're multiplying together. That is why we cube our conversion rates at the end of these questions. Okay? Anything from you guys? All right, I'll put the questions that I've assigned for this exercise at the top of the OneNote page. Otherwise, let's go.